Okay, I want to welcome everybody to what is officially day 3 of the TUG 2020 online meeting, in the annual meeting of the Tech Users Group. It's day 3 because it's morning in Europe, and we've got a few people from Europe here now. But for me, well, first of all, I'm Ross Moore. I'm giving Paolo a very well-earned rest. He's probably asleep at the moment, or at least hope he is. He's certainly been working hard for quite a while. But for me, in Sydney, Australia, it's getting towards the evening, so 5 o'clock in the evening. But for our first speakers this morning from India, for them it's what, about just after midday over in India. Okay, so the first paper, there were 3 names mentioned, but the first one will be our speaker. So it's Apu, Aravind, and Rishi, 2 of whom are here, and Apu will be doing the presentation. These guys, they're from STM Document Engineering, known as STM Docs. Basically, they're typesetters of scientific, technical, and medical journals and books, and service providers to many leading publishers and authors across the world. And I believe they work in conjunction with River Valley Technologies. And if you haven't ever visited them in Trivandrum in India, it's something worth doing. They're really good guys, and you can see how they work through things, and they've got a lovely campus, and just good stuff. If you get the chance to go there, take it. Okay, I've been there 3 times in the last 20 odd years or so. Okay, but anyway, let's have Apu. Hand over to Apu, and when he's ready, he can put up his slides and take it away.
Thank you, Rose. So, hello all. I am Apu. I am an employee at STM Document Engineering Private Limited, a typesetting company located in Kerala, India. In this session, we are discussing about the need for a tool to profile LaTeX document sources and the role of LaTeX hook mechanism in implementing that tool. So, I will be sharing my screen now and my presentation. So, STM Document Engineering, in short, STM Doc started as River Valley Technologies, India. We founded by CVR brothers, C.V. Radhakrishnan, C.V. Rajendran, and C.V. Rajagopal in 1994. We typeset academic journals and documents for universities and publishers. And we also do research on LaTeX and conversion of LaTeX documents to other markups like XML. We are using TUG for more than 25 years. STM Docs provides LaTeX author proofing service called Neptune to one of the largest academic publishers for the last 4 years. We also provide support to others during the submission process of their manuscripts. We have contributed a number of LaTeX package and manuscript templates to C10. Among them, else article and cast templates are widely used among academic authors. It is our experience in providing LaTeX support to others that led us to designing a profiling system for LaTeX manuscripts. So let's check what is the need for such a LaTeX profiling tool. By profiling, we mean the analysis of the LaTeX document for non-standard coding practices, verification of the presence of assets file like figures, additional input files used in the manuscript, and the requirements of the publisher for preprint PDFs. LaTeX is not just a markup language to generate a document. It is a programmable language for preparing documents. This programmable nature of LaTeX allows authors to customize every aspect of the document. This permissive nature of LaTeX leads authors to knowingly or unknowingly indulge in non-standard markup practices. For personal document typesetting, this does not arise any problems. But in the case of academic publication, journal publishers prefer authors to submit documents to follow a common template and a style so that the article publication process, which involves reviewing, editing, typesetting, proofing, and final online and print deliverable preparation, can be done within the turnaround time cost effectively. Journal publishers provide authors document templates in the preferred layouts and style for both LaTeX and Microsoft Word. Being a what you see is what you get document preparation system and limited customization of MS Word templates, manuscript processing at typesetters end is easier for non-math intensive and Word document articles. But processing of LaTeX manuscripts depends on many other factors, like authors' expertise in coding and coding style in LaTeX, journal submission system, journal typesetters' expertise in LaTeX, etc. Novice LaTeX authors may ignore compilation errors, or they may not follow the instruction in LaTeX templates at all. Authors prolific in LaTeX may use fancy or cutting-edge packages that may not work with submission system or breaks journal's house style. This results in a lot of to and fro communication between the author, the typesetter, and the publisher, which cause unavoidable delays and hardships in processing their submission within TAT. So, LaTeX manuscript submission system needs a pre-submission checking system that checks the completeness and usability of manuscripts so that the authors can be requested to adhere to the requirement of easier journal production. Most of the publishers provide a web-based graphical interface for authors to upload their LaTeX manuscript and to build PDF documents. These submission systems are not very user-friendly. They lack editing features and are fine-tuned for creating PDF documents only in publishers' preferred layout and style. Features like shell escaping, etc. are disabled in this submission system due to security reasons, which breaks the use of packages like minted, TIX, PGF plots, SI Unitex, etc. This results in unexpected errors in the submission system for documents, which the authors can easily compile and successfully in their systems. So these kind of problems create author frustration and difficulties in submitting the manuscript. So a LaTeX profiling and completeness usability check tool will help authors to edit, compile, and fix errors in LaTeX documents, and a checklist that helps authors to make sure that they are following the requirements of the journal. Authors can submit the manuscript to publisher's submission system only after fixing the errors error prompts and completing the checklist. This will reduce the delays at the submission system due to previously mentioned problem and the delays later at the typesetter's end. So this is TechFolio Alpha, a screenshot of the TechFolio Alpha, a tool we designed for this purpose. TechFolio Alpha is a tool being developed by STM Software Engineering Private Limited for LaTeX profiling and checking the completeness and usability of LaTeX manuscripts. TechFolio Alpha is a cloud-based service available as a web application with LaTeX editor and also as a microservice which can be used remotely using API calls. So in this screenshot, you are looking at the web interface of TechFolio Alpha web application version. On the left side, you can see a file manager where the author will upload their manuscript files. They can edit the files in the LaTeX editor, which is shown in the middle of this picture. So on the bottom of the LaTeX editor, there is a log window viewer, which will prompt the authors to fix compilation errors if they occur. In the current LaTeX submission system used by most publishers, authors have no option to view the errors in their LaTeX documents while the document is being prepared. The error log will be generated only after the document is compiled, and it will be difficult for the authors to troubleshoot what is causing the problem in the submission system. So a real-time compilation and error displaying will help the authors to troubleshoot the problems quickly. On the right side of this picture, there is a PDF and checklist viewer. In this figure, we are showing the checklist report of the current manuscript being compiled here. Depending on the severity and status of each checklist item, a final score of the manuscript will be calculated by CU tool. If the score is above a threshold value, authors will be allowed to move to the submission system. Otherwise, proper instructions and guidelines will be displayed to authors describing the requirements for a proper submission to publishers. Here in the right side, you can see a table displaying what is the item, the severity of the item, and the status. The safety go status means the validation was successful and the author is good to go with this item. And here 11th item, you can see the bibliography environment not provided status is displayed. So author need to check whether he has not forgotten to upload the BibTeX database to the submission system. So by this way, author can analyze the report and the checklist and correct the necessary requirements and move forward to the submission system and generate PDF there without any problem. So here we will discuss about the objectives and scope of TechFolio Alpha tool. The main objective of TechFolio Alpha is to make sure that the author submits the latest single version of the source material right at the first time. The current submission system used by publishers, authors have to upload multiple versions due to their difficulties in compiling the PDFs at the submission system. So there will be many versions of the documents uploaded to the system, and at the typesetter's end, they have to analyze the document or maybe even have to contact the authors to determine which version of the document they have to use for typesetting. So these kind of confusions can be avoided if the pre-submission tools, filters then only the necessary files and moves it to the submission system. The report generated by the checklist can be used at the publisher, and the supplier workflow management systems can be used them to improve customer experience. FAQs or chatbots can be integrated to the system to walk others through the process smoothly. TechFolio Alpha being a cloud-based web service or microservice for authors and publishers, so they can use TechFolio Alpha without the need for local tech installation. So here we will see how TechFolio Alpha works, what's happening behind the TechFolio Alpha. TechFolio Alpha uses Python and Perl for processing and analyzing LaTeX source files, log files, and auxiliary files to generate the CU checklist and reports. CU means completeness and usability. Details like mixing input files, checking for the use of recommended class files and packages, etc. can be detected using the above methods. But a few critical ingredients for the report can only be extracted with the help of LaTeX during the compilation time. It is preferred to minimize the changes to other manuscripts to avoid confusion in later document preparation and typesetting stages. So we used LaTeX hook mechanism and eToolbox packages patching commands to extract the details for the CU checklist and the reports efficiently and conveniently. So here we are going to check and see what's the role LaTeX is playing in this profiling system and in the process of profiling the document. We load a file containing LaTeX macros that hook to the class file and packages used in the manuscript before document class. This is the only change in the manuscript needed for preparing the author's document for TechFolio Alpha. Here we discuss 4 cases where we used LaTeX hook mechanism in our CU tool. The example mentioned here are for academic publishers that uses else article class template for author submission. Pre-compilation analysis of the manuscript in TechFolio Alpha configured for the said publisher's submission system will strongly recommend the authors to use else article class if it detects a different class file is used in the manuscript. Majority of the authors submitting to the publisher use else article class since it generates preprint PDFs as per the requirement of the publisher. Also, the publisher recommends using else article class in their guide to other pages. We load a text file, else article pre-hooks that contains the hook macros for else article class. This pre-hook file contains publisher and journal-specific configuration for the documents generated using else article class. So this is the first example using the hooks. The first example is the method used for detecting sensitive macros redefinition. Authors may redefine macros used in the class file intentionally or unintentionally in their documents. Even though the authors get already defined errors during compilation, author may use def or renew command to skip these type of errors without considering the reason for the error. Or the package loaded by the author may redefine the macro without showing any errors. This hook checks for author definitions or definitions of packages that overrides already defined macros in the class file as per the publisher requirements. Such macros, if goes undetected during submission, will raise style error flags later during the journal production at typesetter's end. And this will cause delays in the article production as the typesetter need to contact the journal house and the author to require author to query whether to keep the custom style or not. If such cases are not detected at submission stage itself, authors could explain the rationale behind changing the macro, or author could stick to the original style defined in the class file if the redefinition was unintentional and does not have any particular significance. Now we are going to check the implementation of the hook. We create a C list that holds the names of such a sensitive macro. In this example, we are using two commands defined in else article class, text marker and author. We do not want authors to change the definition of these commands in their documents, as they are defined as per the style of else article class. The style of the publisher that comments else article class. Then we define two property lists. These property lists hold the hash value of the macro definitions listed in the above list. These hash values will be used to verify if the macro redefinition has been happened later in the document and the definition and these commands were modified by the author in the document. So here we hook to the class after hook using the add hook command provided by LaTeX 3's hooking mechanism. And we hook to the class after and iterates through the C list that contains the macro names and calculate the hash values of the definitions of this macro. So we iterate here, iterate the list that contains the sensitive macro names, and using checkmd5 sum command and CS meaning, we calculate a hash value which will be unique for each macro definition. This value is stored in the property list we created earlier, the first property list we created earlier. So we are storing this hash value in G else article class macro hash property list. Now, in the next step, we hook to the end document hook. And again, we iterate through the C list that contains the macro names and calculate the hash value of the macro definitions using the checkmd5 sum package and CS meaning. We push the hash values of these macros to the second property list. So it's the same process as mentioned earlier, but now it happens at the end document. So if author has made any changes in the preamble part or after the begin document to these sensitive macros, the definition of the macro will change and the CS meaning of the macro will be different to the CS meaning of the macro we found out during the first hook. So the hash values in this property list will be different from the hash value in the first property list. While still in the end document hook, now we compare the hash values of the two property lists. If author redefined the definitions in plist in preamble or begin document, the hash values will be different, and we are comparing the hash values here. When we identify such a difference in hash value, we add it as a checklist item with the description of the problem to a custom XML file. We write this custom XML file using LaTeX 3 write mechanism, and that's what you can see here. This XML file contains elements which has a type attribute and an ID attribute. This type attribute and ID attribute helps in identifying what is the checklist item and the problem here for better analyzing the problem using checklist. This type attribute and ID attribute, which makes it easier for programming languages like PHP or JavaScript, which is used in generating the final report that is visible to others in the web interface, will help them to identify and process the problem accordingly. This XML file is processed later by the report generation tool to generate a report which can be viewed in TechFolio Alpha web interface or using a web browser in the case of microservice. Also, we can add a report in the end of the generated PDF document, which author can view in the PDF viewer of TechFolio Alpha as well. So one problem we noticed in this method is that if the author used robustify command to make the command robust, it will be flagged as redefined macro. But author can check that and verify it and move forward if it doesn't cause any problems. But such cases are extremely rare, and this is a very effective way to find if author has modified any core macros. So now we are going to see another example. Here we look at the case where we are going to check whether the author has used mandatory items in the documents. When using class file suggested by the publisher, there will be some mandatory commands defined in the class file. For example, macros like keywords, corresponding author, etc. One way to detect if author have not missed using these commands is to add error messages if they are not used. But in that case, popular packages like else article class, authors use else article class for typesetting general documents for personal uses, like for creating lecture notes, etc. The implementation of errors will create difficulties for this kind of non-academic use cases. Releasing a different version for publishers and non-academic users will create difficulties in maintaining and updating the class file and packages. So again, using hook configuration specific to CU tool will be ideal solution. Here again, we maintain a list of such mandatory items in a C-list. Using C-lists makes it easier to add or remove macros that needs to be checked. And that makes it very easier to add or remove macros. In this example, we are checking two commands, core ref and core text. These commands are from else article class, which is used to tag corresponding authors and corresponding author eners. If author somehow misses to indicate the corresponding author in the manuscript, it will create confusion during article processing at typesetter, and confirmation with the author will be required, which will increase turnaround time. So again, we here maintain a list that contains the names of these mandatory macros. So we here using the adding the two commands I mentioned before, the core ref and core text, into this list. Then again, we iterate through the list using this time using CMD before, command before hook, using the add hook command. We iterate through the list and hooks to macros itself and sets a definition to indicate the macro has been used. So if the author uses this macro, this definition will be set to 1. Then, as in the previous example, we hook to the end document hook and iterate through the list that contains the mandatory macros and checks whether that definition that indicates the usage of the macro has been set. And if it is not set, we write a XML checklist item that will be processed by the CU tool and displayed to the author as an item to make sure that this command has been used for this purpose. It is a mandatory command and author have to use that. Similarly, similar approach is used for checking mandatory environments too. In this example, we are validating the presence of mandatory environments graphical abstract. It is an environment used by else article class for tagging graphical abstracts in the manuscript, which is mandatory for some journals. And another is biography environment used for tagging author biography. Same checking mechanism for mandatory macros are used for environments also here. So a list that contains mandatory macros and the similar hooks, but this time we are hooking to environment before hook. And a definition is set to 1 if the environment is used, and it will be later at end document hook will be checked for the definition. And if it is not there, the item will be added as a checklist item for author to verify. So the next example is an important case. Another problematic item specific to online submission systems are related to package compatibility. The security measures implemented in these submission systems prohibits the use of write 18, since it is a way of sending commands to operating system. Authors who are familiar with the packages like TIX, PGF plots, Minted often intentionally or unintentionally use write 18 streams in their documents. As there is no option to run compiler with the shell escape flag in the submission system, manuscripts which compile perfectly in author system will fail to generate PDF in submission system. Packages that uses write 18 often create process locks in submission systems, which kills the compilation process after a specific timeout. In such cases, authors won't be able to get an error log PDF, which they can use to identify the reason for the submission failure. This often is very frustrating to the author and results in poor customer experience. TechFolio Alpha makes sure usage of such packages are detected and The compilation stops gracefully at the loading of point of the package, preventing any locked process in the server running the submission system or the compilation process. Proper instructions and explanations can be given to others with the suggestions for alternative packages or methods like replacing TIX code with figure files, etc. to avoid these packages in the checklist. Here we show an example with minted packages, which is used for syntax highlighting computer code. You use package name before hook for detecting the use of package. So we are hooking to use of minted package here using the add hook command. We use package name before hook to hook to these loading points of the package. We write the report XML with instruction for others about the problems of using these packages in online submission system. Here what we are doing is we hook to begin document, end hook, and insert an end document command. So that will prevent further compilation and stop the compilation document immediately after begin document. And we also insert end input in the add hook in the package minted, here in this case minted before hook. So the further processing of the commands in the package will be restricted also. So in the similar example, we also add a hook at the end document to write the report. Using the checklist, we will instruct the author to use alternate packages like listings, which does not require shell escape, or we will ask the authors to create images of the minted program listing code and use them in the manuscript. Along with the hook mechanism, we also use eToolbox patching commands in our profiling configurations. But we prefer to use hooks whenever possible, since it makes the process of creating new profile configurations or enhancing the existing configuration easily. So here I am presenting a overview of this block diagram overview of TechFolio CU service workflow. Before concluding, we will have a look at this block diagram of the TechFolio CU tool. Authors, instead of directly uploading the submissions to publisher submission system, they upload their manuscript file to TechFolio CU tool web interface. Others can edit and compile the manuscript files in the CU tool's LaTeX editor and fix compilation errors, which will appear as prompts in the web interface. So others can create error-free document using TechFolio CU tool. During the compilation, our LaTeX hook configurations will extract necessary details and create checklist report XML. So the first block is about author uploading the file, and every process will analyze the text file for missing files, etc. And then the CU server, where author will compile the document, and our hook configuration will run here and extract the details and generate an XML file for the checklist. And in the next stage, in the validation stage, the processing part of the CU tool, which uses text processing tools like Python or JavaScript, or PHP, analyze the log files, and also the XML report XML generated by hooks to generate a checklist which can be viewed in the web interface of TechFolio CU tool by the authors. Authors can go through the checklist items that need consideration and check the instructions and modify their manuscript further in the editor. So in this case, the CU server validation checklist will request to author that the submission has not passed the necessary checklist items to move to the submission system. Will ask the author to check and respond to the checklist items and make necessary changes to the document. And support resources like FAQ pages or bots and or human support system will help the authors to resolve the issues if authors can't understand the items in the checklist or having difficulties in solving the problem. So once the issues are solved, again it will move to CU server processing stage where author will compile again and the hook system will again generate a report for report XML for validation. The CU server validation tools will generate again and checklist. And the CU tool validation tool will assign a point or a score to the manuscript using the checklist report generated. If that score, a threshold will be set for by the publisher for a manuscript that if the manuscript does not pass that threshold, author need to check the checklist again and complete the process again. If that score is passed by the manuscript, that threshold score is passed by the manuscript can move to the submission system. Once the validation score for the manuscript calculated by TechFolio tool using the checklist report passes the threshold for safe and valid manuscript score, the manuscript will be moved to the publisher submission system and a preprint PDF will be generated. And the author submission will be registered for processing and publication at publisher's end. So this all concludes our introduction to TechFolio CU tool and how we used LaTeX hooks mechanism in our CU tool for profiling LaTeX documents and checking its usability and completeness. So that completes my presentation. Thanks.
So thank you, Apu. Very good. I think it's a great use of the hook mechanism, the new LaTeX hook mechanism. And so what about anybody else? Any other questions? Oh yes, there is a question here. Who is that? Someone's got a raised hand. I can't tell who it is.
It's
it's
me.
Ulrika, come on, Ulrika.
No, I didn't have a question, but you mentioned that you have problems to check commands which are robust or protected. And I think you can use there the show command that I showed yesterday in my talk. It will show more of a command of the inner definition of a command.
Oh, yes, so I will, that's the new information and I will get that. Thank you.
Yes, and perhaps as a remark, it would be better to use the naming chain of Expel 3. That means to put everywhere your module name at the beginning of a command. Not to use something like G_document, but always G_CU_document. Everywhere a module name. It would be saner, then you avoid clashes with other modules.
Yes.
Okay, and Kaveh. Kaveh wants to speak.
Hello, Apu. This is Kaveh from River Valley Technologies in London. So you're doing this I can see you're doing this for Elsevier. am I right that you're checking to see if the author might have changed the class file, they might have removed.
We are not looking for changes in the class file. We are looking if the author is making any changes to the definitions or macros in the class file. If author redefines anything defined in the class file, this will create a checklist item and flag in them.
Okay, thank you.
If the author is prolific to edit the class file, then we can't do nothing much about that.
That was my question. Thanks.
Okay, well, the timing here has been absolutely great. But first of all, is anyone else? Any more questions from anyone? Anyone? No? Okay. Okay, well, in that case, let's thank Apu. I suppose not many others can do that, but anyway, thanks for a very good talk, and